So in number 58, we have a pretty straightforward angular momentum conservation problem. Halley's Comet moves around the Sun in elliptical orbit, with its closest approach to the Sun being 0.59 astronomical units. That's an unusual unit where one astronomical unit is the distance averages between the Sun and the Earth. And then its farthest approach is 35 AUs. This diagram does not quite do it justice. It goes way beyond Jupiter's orbit. What happens, though, is that Halley speeds up as it moves towards the Sun and slows down as it moves away from the Sun. In this case, they give us the comet speed at its closest approach is 15.4 kilometers per second. So fairly quick. And the question is, how fast is it going when it's the furthest point away from the Sun? And they tell us that you can neglect any change in the comet's mass and assume that its angular momentum about the Sun is conserved. Now you might say, wait a second, how can a point mass have angular momentum? But again, remember, there are two formulas for angular momentum, and the one we want to use this time is the one for a point mass, where you can just take mass times velocity times the perpendicular distance between the pivot point, which in this case is going to be the center of the Sun, and the comet. So what do we know in this case? Angular momentum at both points must be the same. And now I'm going to do something a little bit unusual. Instead of converting, first of all, Halley's Comet's mass cancels, assuming it doesn't lose any mass each time it goes around the Sun. In reality, that is not quite true, but they tell us angular momentum is conserved. But here's the unusual thing. I'm going to leave the distance r in astronomical units on both sides. And you might say, whoa, don't we have to convert that to meters? And you could, except what's going to happen in this case? Having the same unit on both sides is simply going to cancel. And so it doesn't matter what units we use. But the answer I'm going to get here for the velocity is going to be in kilometers per second. I'm not sure what the answer key has, but that's probably just fine. So solving this one, very quick plug and chug, we get this many kilometers per second. In terms of meters per second, that would be 910 meters per second. Not a big difference, but I'm not sure which one the answer key might have had, but pretty straightforward. I hope that helps.